Good morning, everybody. Welcome to class today. Let me bring the microphone closer. There we go. So hopefully we got a good stream going on today, since we had some issues last time. But I do think that the stream is up, so let's hope that it stays that way. Let me fix this light. There we go. So, cool. Today we're going to be talking about structs. So we're moving away from the whole sorting and searching and vectors and arrays and that kind of thing, and we're kind of jumping into a new topic. That's the final topic of the course, actually. The official topics of the course, the final topic of the required parts of the course, I would say. And so this is basically, again, I said this at some point, but you got all the tools you need to program whatever you want, potentially. Now we're learning more of additional tools that can help make the job easier. You know, it's a lot easier to, if you have to put 5 screws in, you can use a screwdriver. But if you got to put in 1,000, you might be better off using a drill so you don't get so tired, right? So now we're kind of learning, you know, the drill. Yes, we have a screwdriver. Yes, we could do 1,000 screws with a screwdriver, but it's a lot easier to do them with a drill or, you know, other tools that may make things easier for us. And so structs, you could think of it that way, as another tool in your toolbox that will allow you to program it. In this case, it'll allow you to make your code a lot better shaped per se, and also it'll make it easier when you transfer information from functions into functions. So and if you haven't done the battle royale assignment, then after today you could totally change it and use structs, and it becomes a lot easier, actually. Not easier, but just easier in the sense that it's easier to handle code between functions and that sort of thing. Anyways, let me pop that up. So there we go. That is today. And yeah, let's just jump right in. So first, why don't we go ahead and let's define what we're trying to make easy before I tell you how structs make it easy. 2 things. The first one and most obvious is functions. Let's think about functions for a second. You know, with functions, we got the return type, which could be void. Then we got our little identifier. So let's say it's some function foo. And then we got our parameter list, right? Okay, so suppose that we are working in a project that requires 20 parameters. That means potentially 20 things here, right? And then, if what we're trying to return requires more than one parameter, sort of one value to return, you can't really just have that return type, you know, be one value, because if you need more than one, then what are you going to do, right? Like if you need to return 2 integers, yeah, you can only return 1 integer at a time, right? What if we could package them all together and return them as one box? That way we still maintaining our whole, we can only return one thing, but in reality we can return multiple things inside this little box. Okay? Similarly here, we got 20 parameters. What if we could just package this again into a box that contains all 20 parameters and then just have a single parameter? So 1 parameter in and 1 parameter out. And so you can see how that could be very useful, because you don't have to do this whole like int a, comma, int b, comma, maybe float c, string, blah, blah, blah. You know, that's very annoying, especially when you're passing things in. You got to keep track of all the parameters and everything. And again, you can't even do more than one here. So if you didn't use this method, you would do what I showed you, which is you could pass by reference and then have some parameters here that are also used for returning out as well, right? So if you have to return out 10 things, we could either reuse these if we're allowed, or we could just make 10 more and then make them come out. So that's one sort of advantage of what we're going to learn, is how to make these boxes. Not required. Yeah, you can go the hard way, but makes it nicer and faster to code too. The other side of things is when you're coding something, and this kind of gets you into the idea of what 202 is all about, which is object-oriented programming. Because it turns out that these little boxes, we can call as objects. And so what is object-oriented programming in the simplest sense is a solution to a problem, and that problem being keeping track of things together. So normally, when you're writing code, and in general, when you're doing something, when you're doing a task, if somebody tells you, I want you to go change the oil of your car, okay? When you think of that task has two main things that you got to worry about. And one of them is what you need to do and what the tools are that you need to basically do the job with, right? If you don't need any tools, so you need your bare hands, then all you got to do is just go there, and then you got to read the instruction manual on how to change the oil, right? However, you may require some tools such as an oil changer, like little grip thing. Maybe you need a jack so that you can lift the car and get beneath it if you have a low car. And also, it might be beneficial to have a tray to receive the oil. But more importantly, you need new oil, right? You actually need new oil. Otherwise, like, you're going to drain the oil, change the oil filter. You need a new oil filter as well. But if you don't have new oil, what are you going to do? Put the old one back in? Yeah. So you need to make a list of the stuff that you need to do it and how you're going to do it. The same sort of concept of preparing things ahead of time is the same idea with object-oriented programming. We want to create a little bucket that we can carry around to make things easier. And in our bucket, we want to keep two primary things. And one is the data that we're dealing with, and then the operations that can be done on the data. So for example, suppose that we were trying to write a calculator that could figure out because we did that at some point, the perimeter and the area of a rectangle. In that case, the data is going to be, try refreshing. In that case, the data is going to be length and width. That's the hard data that we need. The operations that we need to do on that data are computing the perimeter and computing the area, which are functions, right? So it would be nice if we could compact everything into a nice little bucket or box that carries both the functions and the data to work the functions on. So right now, when you're writing your functions, such as function is take old oil filter out. That function is just a global function that you're putting in your code, right? But does it make sense to think about take old oil filter out in the context of you mowing your grass? Not really, unless if you have an automated mower and the thing breaks down or something. Maybe they have oil counts, I don't know. But it doesn't make much sense. So when you're writing the function change oil filter, or when you're writing a function that means refill oil, those are very specific to a car change, oil change operation, right? And so those functions, they don't make sense that you put them in a global scope because they're useless for other purposes. So it would be much nicer if you could just self-contain them in this little box that is all of your oil changing stuff, including your data. And yet again, with the example with the rectangle, when you're saying compute perimeter, that compute perimeter function is probably related to the shape that you're working with. And if you're working with a rectangle, yes, it's length times width. But if you're working with a triangle, perimeter is computed differently, right? You don't actually do length times width. And so, same with a circle, pi d for figuring out the perimeter, pi times diameter. And so, those are completely different operations than length times width. And so, how do you separate them? Well, I could call one of them area of circle, area of triangle, area of perimeter, and then, area of rectangle. And then we have a perimeter of rectangle, perimeter of triangle, perimeter of circle. Yes, but still, now you're just writing a bunch of functions with names, and it's kind of hard to keep track of. And yet again, your code, all the code has access to all these functions when they don't need to. It would be better to limit it to only the pieces of the code where you need to use it. And by putting in this bucket, you only use the bucket when you have to, and the bucket contains the functions themselves, and then the data that those functions need to perform the actions on. And by associating the data with the functions themselves, you no longer have to worry about parameters, because that data will be accessible to your function. You can think of it as if it was a global variable. It will be accessible even if you don't pass in as a parameter. And I'll show you how to do that. And that's very, very useful because if you really, really hate, and I guess this is the reason why you should do it, but it's just one of the pros. If you really just hate using parameters in your functions, then the only parameters you are going to need into those functions anymore are going to be sort of input stuff. But any data that the function needs and that it returns can be kept potentially as a what we call class variable or struct variable or member variable. And so structs and in general object-oriented programming, which is what a class is, and structs and classes in C++ are for all intents and purposes identical minus one thing, are very, 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 very useful at containing data. And the idea of containing data is important because you want only the code that you write to serve the purpose that you need without affecting other people's code. And we know global variables are bad, right? Global functions are not as bad, but they're still kind of iffy. And so by keeping things in objects, you are no longer making per se a global function, which is nice. What else? When you get to 202 and you talk about inheritance and those kind of things, you can then mix and match these things and modify them. And there's a lot more usage to it that makes them even better. So even if you're not fully convinced, there are more things that allow object-oriented programming to be so popular in today's world of programming. But before we get there, we kind of have to talk about structs. So again, structs are going to be how we're going to achieve all of this. So now that I talked about that, let me go ahead and define a couple of things. And the first one is going to be, of course, what a struct is. A struct in C++, also known as a record, depending on who you ask. And I'm just going to go ahead and write the definition from the book. It is a structured data type. By the way, I think I already announced it, but we are going to be changing books, which again doesn't affect you for this class, but for future classes, so for future 202s, normally you would have used the same book you used for 135 because we save money that way for you guys. But now we're going to switch to a completely free book, which is good for people that haven't taken the class yet because then they don't have to buy the book. But for those of you that already take the class, which are pretty much all of you, at least in this class, and you bought the book, then it's not going to be useful. I mean, it will be useful as a reference, but it's not going to be the one they use in the class. They're going to be using a free version of a free book. So I would still keep it as a good reference. But I guess if you're short on money, you should probably sell it before people realize that we're switching the books. You might actually fool someone into buying it. But don't tell anybody I said that, I guess. But I would frankly keep it. It's a good book. I actually like it more than the one we're going to use, but the other one is free, and we do want to save you guys like $100 by switching to a free book. So, yeah. Anyways, so let's see if I wrote this right, because it's kind of hard to talk and write different things at the same time. So hopefully I wrote this right. Let me see. I'm going to read the version out loud here. Hopefully it's the same thing here. A structured data type with a fixed number of components that are accessed by name. And then and here's the cool thing, because so far you could kind of achieve this with an array. But the nice part is the second part. The components may be of different types, which are the heterogeneous types in comparison to the arrays, or vectors, which were homogeneous types, right? So let me see if I wrote a structured data type with a fixed number of components that are accessed by name. The components be okay. So I wrote right. Cool. So that definition is very similar to the one that was from the arrays, but the big difference being that whereas an array, things have to be the same data type, here they can be a mix and match. And furthermore, there can be even functions in the mix, which is pretty cool. But only in C++. In C, you can do it, but you have to do some nasty things. The old school structs only allow you to do just variables, not functions. But C++ does allow you to do both, which is very important. That's how you achieve object-oriented programming the right way. Okay, and then we have one more definition, which is pretty simple here. If I could spell this word, record. Okay, so a field. What is a field? A field is a component of a record. So when I'm talking about those class variables or struct variables, or just the variables that are associated with the struct, one of the names that people use a lot is the word field for them. And another one, I suppose, is just a member variable. So member variable or member function. I personally use those, but the book has the word field, and I have seen the word field used a lot, especially for compiler people. They like that better. Okay, so how do we declare a struct in C++? Like, let's actually go ahead and try to make one. Okay, the syntax is a little bit different than what you're used to, but you'll pick it up. And so with a struct, and by the way, this is identical to class. In fact, I'll even show you the class example in a minute here. You write the word struct, and then you give it an identifier. So I'm going to put the word type name, but really this is just an identifier. And by that, of course, you still got to follow your C++ rules, which are no numbers in the beginning, only A through Z, upper or lowercase, or underscores are fine. And then for the second character or later, yes, you can have A through Z and underscore, and also you could have numbers. So yes, the same rules apply. Then from there, it's kind of like if you were doing a function, you put a curly bracket, and then you're going to leave some space, and then you close this thing by putting another curly bracket and a semicolon after. Kind of like the do while loop a little bit, you know. That was we saw a semicolon like that. You don't normally put the semicolon when you're working with functions, right? But you do with a struct. And it's okay if you forget it a few times. You will get an error, and then you will fix it, and you'll be okay. But yeah, you got to get used to putting that semicolon at the end of this thing. Okay, we're not done yet. I mean, this is technically a struct. We have declared a struct, but it's kind of pointless because there's nothing in it. The cool part is that we can now put things inside. And so inside of here, you can declare any functions you want or any variables you want. And so how do you do that? Just like you would normally in any other location. You basically put the data type of the variable, so such as like int or whatever, and then another identifier, which we'll just say it's the member name. But again, that's just an identifier. Obviously something different. Don't use the same ones, but you know what I'm saying. And then semicolon. Let's say you want to put another one in. All right, sure, data type. Member name, same thing. Let's say you want to throw a function into the mix. For the function, it's just going to be basically the same syntax as a function. So you have your return type, your, I suppose, member name, since we're following the same syntax here. So the function name, basically. And then your parameters, if there's any. Usually, if the function is a type that is accessing information, they will be parameters. But if it's just returning stuff, there's two main types of functions when you're talking about objects and object-oriented programming. There's accessors and there's mutators. Accessors access information. They only read data that is contained in their bucket to the outside world, basically. Because you could think of the bucket as an inaccessible thing by the outside world. And if you want to get in there, you need permission, and you can't get permission. So the only people that can give it to you, information, are sort of the messengers who work for the object, and those are the accessor functions that can go in, grab the data, and bring it back to you. So for those, you usually have no parameters. You just call a function that says like get x, or get the length, get the width, and then go in there, and then they just return it on the return type what it is that you're trying to access. The other kind of functions are the mutators. Those are the ones that actually modify things in the bucket from the outside world. And for those, yet again, they're messengers, but they go to the outside world, take the data that you're going to bring into the bucket, you put it as a parameter there, they bring it in the bucket, and then they actually modify any struct or class variables, those member variables. They modify those, so it would be these guys up here. They modify those with the data that was brought in. And so those are mutators, okay? So, all right. So going back to this, we got a return type, member name, parameter list, and then Do I want to? Yeah, we'll do this the easiest way possible. So in this case, the reason why I kind of stumble for a second there is because there's two ways that you can finish declaring these functions. One of them is you just put a semicolon, you call it a day for now. But then you got to go back later on and define that. So you can think of this as like a function prototype inside of a struct, but you still got to go and define that function fully, right? That involves using the scope resolution operator and so on, and I'll show you that later on. But for now, the easiest way possible is actually define the function in here, which means put a curly bracket, and then I guess we'll need a little bit more space probably. You could do everything in one line, but it's not good to practice because it looks kind of nasty. Put it like that, and then basically put whatever code you have there. So, body of function. I don't think you call it that. I think function body. I guess I flipped that for some reason. It's like name of the member versus member name. So okay. So that's going to be your function. And of course, if it's a valid returning function, make sure you return at the end of it whatever it is that you're returning, okay? And so this is going to be our most basic example of a struct right there, okay? I'm going to get rid of this arrow because I feel like that'll confuse people. But all of these, the word name, member names there, they're all identifiers, okay? And you'll see when you see an example. Okay, so now what if I wanted to do a class? It's actually the same thing. So I'm going to copy and paste it even. Is the ampersand by reference a type mutator? Where did I put an ampersand? I don't think I put an ampersand anywhere in this thing. But if you're talking about the general ampersand in C++, that is an address. That is known as the address of operator. And all that does is return to you the address in physical memory where such a variable is located that you would associate with that ampersand. So hopefully that answers your question. Maybe you're talking about oh, I see kind of what you're trying to say. Well, okay, so in a way with the ampersand, yes, you could modify things, but that's not the way we're going to be using it here. In fact, it's very rare to pass to modify things with directly using the ampersand because usually you're making copies to the struct. So yes, ampersand allows you to modify things, but not exactly useful to us right now, if you see what I mean. You'll see, okay? Yes, no, you need to know what ampersand, the ampersand is passed by reference. And yes, passed by reference allows you to modify variables. I suppose you could say that because of that, it allows you to mutate things, but that's not really the meaning of what mutator means, because mutator is very related to classes and structs. And again, so yeah, I don't know. I see what you're saying, and if that makes sense to you, but that's okay. But that's not really what the mutator term is usually applied to. It's not really applied to passing by reference and being able to modify variables in that way. So yes. Okay, so anyways, I went ahead and copied and pasted it, and now I'm going to show you the class version of this. All you got to do is change the word struct to class. That's it, done. GG, easy. And now you know what classes are. So I said that there's one difference between struct and class. And in this class, pun intended, I guess, we are going to be just really looking at structs. And then in 202, you will be looking at classes. But what are the difference between these two things? They both compile, but there's a fundamental difference. And it's just one thing, actually, but it's quite fundamental. And it has to do with the whole idea. I was giving you an example of the bucket and kind of having this big border that doesn't allow people to move across, and you have to use the messenger functions. And that really only applies to classes, because the big difference between struct and classes in C++, can be changing in other languages, but in C++, is whether the members of the struct or class, which means the variables and functions, are public or private by default. Now, what does public or private mean? Okay, so for me to be able to really explain that, you'll have to see it in code. But I'll try my best before you actually see what I'm talking about. What I mean is the following. When you declare one of these objects and you're trying to access the member variables, if you just try to access it directly and it's a struct, you can do that, no problem. It's like there's no walls. Free entry and exit into our bucket, no problem at all. There's no need to have the messenger functions. You can still have them, but they're, I would say, in a way redundant at that point because there's no control to limit the data flowing in and out. That will be a struct. A class is a super closed out bucket that does not allow any information to go in and out. And the only way that you can pass information into your bucket or take it out is going to be using your functions. That's what we mean by a private variable versus a public variable. However, you can just as easily convert a struct into everything being private or convert a class into everything being public by using a public and private keyword. You put the keyword like that, and then you put 2 colons. Yes, you do, right? Yeah, okay, yeah, you do. As far as I remember, yes. I've done it so many times, but for a second I kind of questioned myself. But yeah, you do. You put colons there. No space between them, although I think the space doesn't matter, actually, to be honest. So, by doing that, when you put the word public, anything beneath is now considered a public variable. That's kind of like, it's kind of hard to, you still use the bucket example, but imagine that if you had a mix of public and private in your bucket, it would be like part of the wall of the bucket is missing. And so you can access those pieces of information per se. It's, different layers of bucket and inside, like a castle. They have the outer wall and then the inner wall of the castle. And, the inner walls where the king lived and the outer walls where like the people lived. People, but like the elites per se, because then the farmers and whatnot leave until like the complete outside, I think, or I don't know. Talk to a British person because they know better. But essentially you could think of it that way. And so you can do that, and then anything beneath the word public will be public. But you can also switch it back to private at any point. So like, let's say I only wanted to make this one public, but I wanted the rest to be private. I just write the word private like that. And until I do so, though, it's going to remain basically public. Similarly here, this is public by default. I don't need to write the word public at all. But I could still do it, actually. It would just do nothing at all. This is like redundant code. However, if I wanted to make it private and make it act like a class, then of course I could just do that. So here's the thing. In your bucket, you don't always want to make everything private. Because if you make everything private, not even the messenger functions can get in and out. You want to keep the messenger functions public so that they can actually go out of the bucket and talk to the people outside and then come back in. And then you want to keep the member variables private, since those are the protected stuff. And so, using the word protected is risky because there is a third type here other than public and private that is known as protected. I'm not going to talk about that one. The only difference that makes for now is that if you do inheritance, which you don't know what it is, it actually makes a difference. So don't worry about the protected keyword. But I guess do know there is another way. There's public, private, and there's protected as well. It's kind of like a hybrid. So yeah, but just forget about that word that I ever mentioned it for now. Push it away. Focus. We got public and we got private, okay? And really in this class, we're really only going to deal with public. I can briefly show you a little bit of private stuff, but public is kind of what we got. Does that mean you can't use public outside of its function? What do you mean? You mean outside of its class? You can use public. If you have a function that is not public, you cannot use it outside of the class, which seems kind of weird. And there are some cases where that's useful. But most of the time, you want to make your functions public. A private function cannot be accessed outside of the object itself. However, it could be sort of an inner thing. So like, for example, let's say that you wanted a super accurate calculator of a circle, right? So the public function can be like get perimeter and get area. But you can have an inner function that does this really accurate computation of what pi is and gives it back to you. And I don't know why that would be the case, but let's say you do that. So that could be an internal function that nobody needs to know what's happening. It's only useful for the class itself to be able to compute a better pi. That's all that inner function will do. And then the outer function, the public one, is the one that actually just computes pi times diameter. So that could be a use of a sort of a private function. Not the best of examples, but it's kind of situational. Usually when you have a helper function, as they call them, that helps to work to code some functions to keep them short, that's when you kind of have a good usage of it. Usually when your code gets really big and you split it into tinier functions, that's what you do. So yeah, you use this all the time too, and at the same time, like, it's hard to think of an example when you're actually just trying to talk about it, but that is the life. So okay, before we go coding, let's actually define one more thing. So no, let's code. I think at this point, let's code. I was going to define the member access operator, but I think we'll do that once we code. So let's go ahead and just code a very basic class, because I think this will start to make more sense when we actually see it in action. And we'll stick to structs for now. But like I said, the reason that I don't usually throw in classes into the mix, but because we do have a lot of time, I thought I would. And also, that way you don't get freaked out when you're like, we're learning classes. It's the same thing as a struct. There's just one difference, technically, the private and public thing. That's all there's to it. So might as well show you both. That way, when you see the word class in code, you know it's just basically, the same thing as what you know already, which is a struct. And in C++, that is really the only difference. So yeah. In C, that's a different world. But yes, okay. Since we have been preaching this whole rectangle thing so far, let's just stick with that one for now. Let's do get perimeter and get area. So we're going to call this a rectangle class or rectangle struct. I'm used to saying class because I barely use the word struct ever in coding. So yes. Okay. So what do we want to have inside our class? See, I keep saying class. Just when I say class, you know what I'm talking about, struct. Okay. Yes. Well, we want to have two variables to define our rectangle, and that's the length and the width. And actually, theoretically, it might be better to make them a double so that we can have fractions, just in case we do. Cool. Okay. And so let's leave it at that for now. Let's just leave it at that. We'll add functions later, okay? Don't see the semicolon there. That's important. That's all part of the plan of getting this to work, I guess. And so now let's go ahead and actually create a struct or create an object of this, an instance of it. Instance is a very popular word, instance. So when you hear instantiate a class or instantiate an object, or sorry, not an object, a struct, that basically means you're creating an instance of it, as the name implies, instantiate instance. And what does that mean to create an instance? It means to make an object. What does that look like in an application? You put the name of the type, and then you put an identifier here. Yet again, but this identifier has to be different. So we can call this like rec1. Because I could have also another one that's called rec2. So remember I said a long time ago, maybe you know, but it's okay, that C++ has built-in data types like int, float, double, and so on. But there's also custom data types. A struct is an example of what you can achieve to create a custom data type. Because here we have sort of I made a typo, but here we have what I would consider to be a custom data type. And as you can see with the custom data type, you don't put int, you don't put float, you put rectangle, because that is the name of it, because that's what you created over here. That's the type name. Okay? And so now this is starting to look like real code, because now you're creating these rectangle objects. However, they have garbage in them. But even if they have garbage, how do we access the garbage, right? We don't have any functions right now, but it's an open bucket because it's a struct that you can go in and out. So how do I actually access them if I don't have functions and they're public? Which they are right now because it's a struct by default public. You use what you have used before actually, and that is, finally we get to define it. I don't know what that noise is the member access operator. Can you hear that noise? It's like weird noise. I don't know where it's coming from. It's like an alarm clock or something. So here we go. Member access operator. And that is the dot. And the way you use it is you're going to put the struct variable name. Use the dot. And then the member name. Like that. Let me see what that noise is. Hold on a second, guys. Can you hear me? Is this good? Is it working again? I think so. Okay. Sorry about that. I want to figure out and shut that off. So, okay. Cool. Great. Thanks. Sorry about that. Okay, guys. So, yeah. All right. So we got the struct variable name, which could be something like rec1 or rec2. Then we use the dot, which is the member access operator. And even though you heard me use that term before, now we can really understand what it means when I say member access. And member access means accessing the members. And what are the members? They're going to be the variables in here. So these are the members of the struct rectangle, length and width. And by using the dot, I am saying I'm going to access length and width. And so I would say something like rec1 dot. And as you can see, even the autocomplete allows me to choose which one I like to pick. That's pretty cool. So let's say I pick length. And then I can set my equal sign, because now I can treat this as just a normal variable, and then maybe set 5 to that. This is me accessing the bucket and putting in a 5 because there's no control of who can go in and out. Let's compile it. You can see that it'll compile just fine. Let's skip ahead a little bit and switch this to class. Now it's private by default. What happens if I compile? Well, I get an error saying that rectangle length is private within this context, rec1.length. As you can see, that will not compile. Switch it back to a struct, and it compiles just fine. Let's try to use the word public. That, of course, is unnecessary because a struct is by default public. As you can see, it compiles just fine. But now, let's leave that alone. So that again is public, but let's make the width private. Will this compile? Yes, it will, because we're actually not touching it. We're not touching length, width. We're just touching length. As you can see, it compiles just fine. However, if I do the same thing, but this time I do width. By the way, notice that now it doesn't even do the autocomplete for it. You only see length. You don't see width in there because it's private. So it's not even suggesting it to you because it knows you can't do that because it's private. So that's kind of the IDE limiting you so you don't see a big list of things to only the things that you can really modify and leaving out the things you cannot. That's why when you're using an actual library from like C++, like string library or something, it doesn't show you a billion things that are in the class. It only shows you the ones that you can access because they're public. So let's say we do 3 there. But now it's going to give us the error that is private because in this case, even though it's a struct, we explicitly made this and anything beneath it private. And so that is that. Of course, if we put it up here, I do believe it's going to give us both warnings. So yeah, there we go. Length and width are private. So anyways, just to show you very briefly, we'll come back to public and private again. But anyways, so this is how you access them. Suppose that you want to print them out. You can do that, and that will print it out indeed. This is also accessing it, okay? Technically, this is, I would say, mutating it, but we don't use that term in this situation. We will use it with functions. And then this one is just accessing the data. 5. So, surprise, we got a 5. We stored a 5, and it's still a 5 there. So, yes. Okay? And so, what shall we do next? Let's make it more interesting by... Let's pass it into a function. We'll do it this way, and then we'll bring the function in. So let's create a global function. Even though we should make this a member function, we will do that. We'll get there. Let's just make a global function so you can see the power of passing these structs into classes, or into functions, and not having to pass in a billion different parameters at once. So let's actually make a function called getArea. And this getArea is going to take length and width and compute them. So normally, of course, the old school way would be to do this. You know, get the float and get the length and get the width. Don't use float, use doubles. Why did I just decrease accuracy for no reason? Like that. Of course, this is passing by value. You can do this to pass by reference, so it's a little bit faster. And then if you don't want to accidentally modify it, you can put const in front of them. That ensures you don't modify something by accident. That's all it's doing. However, you know, this is 2 parameters, so I'm lazy. That's too much work. I want 1 parameter, so I can use my rectangle. So that goes away, and instead we can say we're passing in a parameter of the rectangle type, and then doesn't matter what it's called. We'll just call it rec. And I guess we can still pass by, well, you can pass by both, by value, by reference. As you can see, it'll compile by value, and then it'll compile by reference as well. However, I'm going to be safe about my code. I'm going to put the word const in front because that stops me from accidentally modifying it. I'll show you if you don't remember that. But okay, so the cool thing about it is I can call it right here. Let's do it. Let's actually call it right here when the cout. Call getArea and then pass in rec1. That's beautiful right there. We're trying to get the area, and what are we passing? We're passing a rectangle to it. That code is really, really nice. It's very self-explanatory, and it's very short and concise. But it's going to get better though once we put it inside the function. But it's already nicer than just passing a bunch of floats or doubles or integers in some special order and then have to figure the same order out in here. It's not as good. However, like I said, it is going to get better. But for now, that's all it's going to do. And then in here, we just need to actually multiply them. So rec length times rec width. And we want to return the result of that. We could store a local, like a temporary class function variable, the multiplication, but we can just literally compute it and return it at the same time to save some space and code. 15. 3 times 5 is 15. Yes. Okay. So that worked. It's pretty nice. Just to show you that if we tried here to like randomly change the length of the width for some reason to like, I don't know, 6 or whatever, we get an error saying that it's a read-only object because we put this const as a way to protect ourselves. Because if we didn't, you know, in addition to getting the wrong area, if we were to actually see out again here the rec1's length, you would see that it's totally wrong. You know, it's 66 when it should have been 5, right? That's because we modified it here. Of course, if we pass by value, that's not a problem. See, it still says 5 because it messes up the area because you know, we multiply it afterwards, but it doesn't mess up the original data, right? So this is, however, slower. And when you start passing a lot of things, it can get way slower. So we want the speed without the risk. And how we achieve that is by both passing by reference to get the speed, but then to control the risk, we put the const. So hopefully that's a review of that. Yes, you're right. So yes, so and that's the whole point of this whole discussion is that yes, that's what it essentially boils down to. One parameter, a billion different things inside of it is so much nicer than writing a billion different parameters for a billion different things, right? So yes, it is very, very useful to be able to box these things up. Again, think of the bucket. Instead of passing these parameters individually, you're literally taking all of them together in this bucket, and then that bucket has a really nice handle, and you can just have that little handle and pass it to the function, one thing, one exchange. So much better than trying to carry all the things in the bucket in your hands like this, and you're like, oh, here, take all the, you know. That's annoying, very prone to error. You might mix the order of the parameters and things like that. This is so much cleaner. I think you guys are starting to see that. So yes, good. But it's gonna get a little better than this. Okay, so this is cool and great, but that's not really taking advantage of the true power of object-oriented programming. So now let's go ahead and create a function called getPerimeter, okay? But this one we are going to do inside of the struct. So it's going to be a member function instead of a global function. It's still going to have a return type of double, and it's going to be called getPerimeter. And it's not even going to take any parameters. Doesn't need to. Why is that? Because member functions can access member variables of that specific instance of them. That's harder than it sounds to understand if you've never heard it before. Here's the thing. Right now I have two rectangles that I made. One of them has garbage and the other one has 5 and 3. Let's put some stuff in the second one. Let's say this one has 4. And this one has 6. Okay? Just make it nice looking. Okay. When I say this function has access to the member variables, it means it has access to length and width to the point that I can simply do return length times 2 plus width times 2, which is the area of a rectangle. Or sorry, the perimeter of the rectangle. But you should be asking yourself, which length are you talking about? This length or this length? Because we have two lengths. And it is going to be based on who calls the getPerimeter function. Which object calls it? Rectangle 1 or rectangle 2? Because each object has its own length and width. And the function is going to take the one that the object is actually called upon. So how do you call the getPerimeter function? You can't just do this anymore. Because it doesn't know who's getPerimeter, what is getPerimeter, where is getPerimeter. You know, it's like, it's not declaring the scope. So this is going to be very similar when you remember string.length or vectors.length. Oh, sorry. There we go. Remember that with the string.length or vectors.length? So yeah, basically getPerimeter requires an object to call it. And so that can be something like rect2 member access operator, and you can see even my autocomplete tells me getPerimeter. Okay? So now we're saying for rectangle 2, get that perimeter. And so getPerimeter now, I don't think I can try. Here, let's get rid of some of the extra line feeds so that I can compress the code. And maybe these, we can put it all in one line. Yeah, like that. Okay, that way I can, there we go. You can see all the code at once. So now, when I'm doing this line, now this is the true power of object-oriented programming here. I am saying for object 2, which is the rectangle 2, which has these dimensions, get that perimeter. And so when I call it on rectangle 2, the length and width are going to be the rectangle 2's length and width, which are 4 and 6. And so I don't need to clarify that. It just knows because that's who I'm calling it from. And so if I run this, save it and run it. Oh, typos. Assignment of read is read only. Oh, yeah, I forgot to remove this thing because remember I was showing you about that. $20. 6 times 4. well, perimeter of that. So 6 times, it would be 8 plus 12, which is 20. So yes, the perimeter is indeed 20 of a 4x6 rectangle. So yes, this worked just fine. And so do you see that? Do you understand why this is correct? Why this is giving us 20 and not giving us 16, which would be the perimeter of the first rectangle, because that would be 10 plus 6. It's important to understand that because we are calling it on the second one. If we switch this to 1 here, now we're going to get 16. Because now we're calling it on the first object, the one that had those values. And now we switch it back to the second one. Does that make sense? That's important to understand that. And I want to make sure you guys get it. Otherwise, I can try again, basically, to make sure you guys understand it. But please let me know if it does not make sense. So basically, this allows me now to contain both the functions or the operations that I can do on the data and the data itself. And so this is all nicely contained into this rectangle. So now finally, for the last magic trick, let's go ahead and get that get area inside of our struct. Actually, I'm gonna put it down here just in deep cold storage so that I don't get out of the page again, since it's pretty big code at this point. So okay. So how do we do this? Quite simple. Basically the same thing that we did for get area, or get perimeter, I mean. Just type in get area. No longer do we need any parameters at all. So I guess if you really hate parameters, this is what you want to do in life to avoid parameters. Kinda. And then you don't need to put length. You can just do length, or rect. I mean, you can just put length and width directly like that. If you spell it correctly, that is. So. Oh, and this won't work anymore. Now we gotta put in the object name in the front. And there you go. Now it works. We got our area works fine. In fact, let's just make them all be one of them and then all the second one. So this is all for rectangle 1. We have 15 as the area, 16 as the perimeter, and our length is 5. We just printed that out of nowhere. We can switch these to 2. We could, of course, just have, I'm just trying to keep the code small. Otherwise, I would just make them print both at the same time. But there we go. That's the second one. 24 for the perimeter, or sorry, for the area, which is 4 times 6. 4 times 6, yeah, okay. And then the perimeter is 20. So, yep, we're good now. All right. We are still, though, we're still sort of in a free access to a bucket environment. And let's say we want to limit it a little bit. You, of course, want to make the functions be accessible, because those are our messengers. Those are, in this case, those are accessors anyway. Well, they do stuff, but the point is they don't change anything in the function. But what if we don't want people to mess with our length and width? We can make them private. Actually, we'll just do this with one of them. The spacing doesn't matter, but I like this sort of spacing. So it's nice with the private being a little bit tabbed out, but not fully. So that's why I spent so long doing that. Okay, so by doing that, now I'm getting some errors with width. I'm not allowed to modify the width directly. So how can I get around that? I can create a messenger function whose job is solely to set the width, or potentially to get the width as well. Okay? So how can I do that? Well, in the public section of the code, let's say that for some reason I wanted to put it down here. If I do, then I have to write public again. Otherwise, I wouldn't have had to. Doc's gonna say bye. Go away. What we do is we just make a, in this case, let's say we're setting the width. We're gonna make that a setter, which is a mutator function. That one is a void function because it doesn't need to return anything. If you wanted to return confirmation or something, you could, but not really. And then we're gonna call it set width. And this will require one parameter because we are setting something in and we need to pass in that value. So it can just be called W, or I guess double, because we're sticking with doubles. Okay, so what do we do there? All we gotta do is set width equals to W. That's gonna take the parameter value and set it into width. This, being a member function, has access to all member variables. So this will actually be able to pass them information in. But then we as the outsider cannot access this. So, but we can access set width, so we will tell set width, hey, set width, set the width to 20. And then the width's like, okay. And then he or she goes and sets it to 20. And then it's like, the job's done. So yes, it's a messenger system. Okay, so now we just got to replace these with that. So we still need to tell it which object this, because we can't just do this. We can't just say set width and then put a 3 there, because it's going to be like, which width, what object, where, what, who, why, when. In fact, the real error is just going to be that the function doesn't exist, was not declaring the scope. So just like with the get area and get circle, we need to tell it which objects you want to set the width of. So we're like, set it on rectangle 1. And now that's okay. So that'll get rid of that error. We still got the second one to work with, but that gets rid of the first one. But we can just apply the same to the second one. So rect2, set length, or sorry, set width again. And as a parameter, we're passing in a 6. Okay? And so now, it compiles just fine. As you can see, it'll still give us the right values. So this is our messenger function. This is going to be basically our mutator in a way, because it's mutating information inside. If you wanted to make this a billion times efficient, I suppose you could put an ampersand there and then put a const. But actually, that won't even work in this case, because we're passing in a literal. Oh, ooh, it worked. Oh, because it's a const. Yeah. What you can't do is, I don't think it'll work if you don't put a const, but you put an ampersand. Yeah, that won't work, because this is a literal, so it's not a variable. But by setting a const there, it's okay. So, yes. Yeah, it was. But you don't need to do that, so I'm not even going to put it here to confuse you. That will work just fine. Easy. Okay. But what if we wanted to print out the length as well? So, just because this keeps bothering me, I'm going to label these. Let's label these properly. Actually, I would not recommend this. In fact, I won't show you, but I'll tell you that what you could have done. Get perimeter is run at some point. You could actually make it actually print things out directly. So you could make it print out rectangle, but I wouldn't do that. That's like if your length function, if you're like string dot length or string dot size, if that actually printed out the word length, be kind of annoying if you didn't want it to. So let's keep it pure to just returning data. We'll show you a function that prints stuff in a second. Yeah, why not? Okay, so this should look much prettier now. In fact, yeah, this will look nice and lined up like that. Okay, so let's just run that again. Hey, look at that. Looks cool. Okay. So now suppose that we want to be able to print out the width. Okay. So we go ahead and put our label in. But you can't do this anymore, because remember, it's a private variable now. And so the wall is set up there and he can't access it. You need to make a messenger. You don't have a messenger right now though. You have to set width. But you don't actually have a get width that can actually get you the width. You can only set it, but you can't get it. And by the way, here's another thing about the set width that I didn't get to talk about. One of the advantages of object-oriented programming and the idea of these messengers, you might be asking yourself, why put a wall in the first place, right? Allow free access. Well, here's the thing. This all sounds like political, but it's not. Okay, here's the thing. You want to sanitize your input into the oh, I guess this kind of works with the current world, right? So, you know, imagine like if you just open borders and you let people go all over the place, and they got the coronavirus, right? And they're kind of going into a country, then they could potentially be infected, right? So you want to have a kind of a border control where somebody scans them, right? That kind of thing. Same thing here in that sense. They can scan the temperature. You may want to allow, the reason why you may want to have a messenger function is because you can control the data that goes in to avoid potential errors. One of the things could be, for example, you can check whether the number they passed in is a positive number. Maybe you don't want to have negative numbers. You could check that. You can say if W is greater than or equal to 0, then you can set the width to be just directly what it is. Otherwise, you know, if, and I guess I'll be consistent, I'll put my little curly brackets. Otherwise, you know, it's a negative number, so maybe you want to just set the width just to be 0, but also maybe you want to print out a warning, width is negative. Okay, so you know that could be like a thing. Like you may want to control to avoid having negative numbers be passed in, and so you can avoid having to error check later on if you do the error checking now. You do the error checking as early as possible so that you only do it once. Otherwise, you have to do it in every little tiny computation, right? Now, it doesn't really matter for rectangles. So while you multiply, you get a negative value in an area, big deal. But it might matter for things where you're dividing by 0 or that kind of thing. So, you know, it's good to sort of have that control of cleaning your input and so on, okay? So that's one of the big sort of advantages of having this messenger system, that you have a better control of the data flowing in and out. Also, there's a little bit of security involved. You may not want to allow people to modify width at any time of their choosing, because I said it once at some point, but I'll say it again. When you're coding, the reason why you put things like constants in your code is not to make your life harder. I mean, you could just make everything a variable. You can make pi be a variable, but why would you? Pi should not change. It should always be 3.14 and things like that, right? So the reason you do const is to protect yourself so that you actually get errors if you if you make mistakes. Because it's much worse if you don't catch a mistake, code compiles just fine, it runs just fine until you get to that special edge case that you made the mistake on, and then the whole thing explodes and crashes and you got an angry customer. So the whole reason of making all these sort of const things and whatnot is to protect yourself by giving you an error at compile time that you're like, oh snap, I'm glad that it was caught. Same thing here. By making variables private and having all these special checks, you sort of help to avoid any potential mistakes that you would otherwise would have gone unnoticed and you would have made. So that's the whole idea between public and private. Also, when you got a lot of code, you test this code, you know that this rectangle function and the rectangle object works really well. You tested all possibilities. The code is safe. It's fully functional. But it's fully functional as is. However, if you give it to somebody else and they go in and mess around, they try to change the length and the width directly, and they break the code, they're not going to be angry at him. They're going to be angry at you because you made the code. Even though he made the mistake, they're going to all look at you and blame you. So what do you do in return? You're like, no. To avoid another developer screwing my things up, what I'm going to do is I'm going to set these variables to private, so he can't modify them unless he modified the source code, which it's not allowed. I'm not letting him modify the source code. So by setting them private, all he can do is access the width and the length by using the messengers functions, but he cannot modify them. And allowing that to be the case protects me from other people breaking my code and ensuring that my code is safe to run. Whatever craziness they try to do, they can't break into my code, which is a good thing. And that's kind of the other reason. It's not necessarily for security, but it's more for protecting against, mistakes, basically. They're not going to do it maliciously. If you want to maliciously get into a private variable, you absolutely can. If you take my 202, I'll actually show you how to actually quote unquote hack into the variables. It's actually, I have an assignment like that, and it's called Crack the Vault, and I'm going to reuse it probably the next time. I think it was the favorite assignment of all the 202 assignments that I gave, so it's pretty cool. But yeah, so by no means is this secure. It's more of about protecting. It's, what do they call it? It's an honest protection, or honest man protection. whatever they call that. Basically, it'll keep people that from accidentally doing something bad, but people that really want to mess things up, they still can. You know, that's what it really means. There's a term for that, but yeah, it's like a fence. A fence is not gonna keep out criminals. It'll keep honest people out, but a criminal can hop over it and get in, right? Especially if it's like a picket fence, you know, like this high or something. So yeah. Okay, so hopefully that understands the whole spiel why we make things public and private. So let's go ahead and actually make, and of course, you may not even want to have people access the width at all. You may want to have them set it once and never be able to modify it again. You could also do that. But for now, let's go. What can be very useful to always have is access to the width as a value to be able to read it. So we need to have what's called a getter function. That's the accessor function, so that we can still print out the width. So for that one, we're going to make a value returning function. We'll say double get width. Doesn't need any parameters, and all it's really got to return is our width. Like that. That's it. That's it. That's the full function right there. And then we just got to call it. I think you could see all of that. Hopefully you can. Yeah. There you go. Where do I have typos now? Oh, that sounds like a very bad typo. If w is greater than or equals to 0, where did my 0 go? And then I forgot my parameters. Oh, sorry, my parentheses. There we go. Okay, we're good now. Area, width, length, and rectangle. I meant to say perimeter there. Rectangle and perimeter have the same number of letters. That might be why. So, yep. What else? The most important part is that you understand the part about the structs and the part about being able to keep variables as members, and that you can use the member access operator, the dot, to access them. That's the most important part. That's the 135 part. Doing the whole function and private and public, that's the 202 part that you don't really need to know yet. But you need to make sure that you understand that you can create these structs that can keep multiple data types in there. So maybe let's go ahead and move on from this example so I can show you that. But I'll do one more function. And I'm going to call this function a print function. So this is another one of those useful functions to have when you're writing code. The object is something called print. And what does print do? Well, when we call it, we basically will be calling it like cout rec. Let's do rec1.print. What is that going to do? Well, it's your code. It can do anything you want. But in my case, I'm going to make it print out basically the same thing that I was printing in main, except now it's a function that does it. Like that. And then I'm actually going to leave it like that. Or nah, I'll change this one. And then I'm just going to get rid of this to kind of trip you out. Void print, get area, width, length, get perimeter. Where's the error? Oh, no, that's fine. Oh, yeah. Bad thing here. I did not meant to do the cout part there. Okay. Yes. What did you learn about operator overloading? So, okay. Yeah, I'm just calling a function. I'm not trying to see out what the function returns. It's not returning anything. It's a void function. So that's why the big error. So anyways, okay. So this is the other scenario that you may see. Functions calling other functions inside of the object per se, or the struct or class. And so here, I'm going to basically want to do the same thing I did here, except now I'm making it a function called just print. That way I can just say like rectangle dot one dot print. And so how do I do that? Well, for get area, I still got to call get area to compute it. But notice that I don't need to put I don't need to put a rectangle there. That's okay, because like, look at how I'm calling this. First, I'm calling rec1 print. So I know that I'm calling it on object 1, the one that has the dimensions of 5 and 3. So once I go into the print function, I know that I'm dealing with rectangle 1, and I know what those dimensions are. So when I call get area here, the reason I don't need to put the object name is because I'm already in the object when I'm calling it. So it knows that I'm talking about object 1. And so when I do get area, and I go into get area, and I return length and width, that's object 1's length and width, because that's what the original call was on. Okay? Similarly, I can access by local variables, because I know with member variables, because I know who I'm called on, again, rectangle 1. So I can do width and length. Also, because I am accessing it from within the function, it doesn't matter if it's public or private, the variables, because any member function can access any variables, whether they be public or private, because it's a member. You can think of it as like people living in the same household can access other people's stuff, even if it's private. Maybe they shouldn't, but they can. And so that's kind of how the comparison can be. And then, of course, get perimeter, yet again, doesn't need an object in front of it, whereas these do, because, again, I've already called it on an object. So I am already being in an object when that gets happened. This is an example of internal functions. Although these functions are public, they could have been private for all intents and purposes as well. So, yeah. And so let's go ahead and run this. And maybe, it's okay. Yeah, that's not okay. We need a little line feed there. So let's just put a line feed. Okay. So this is the object 1, and then this is object 2. Okay? So object 1, or so actually object 2 and then object 1 down here. Object 1 you can see is 5 by 3, and that is the area, and that's the right perimeter. So it all works just fine. So that's the other kind of function that you might see. A function that is no parameters. It's a void function. Typically, it's just a accessing function that just prints stuff out to the screen. And yeah, so this is so much nicer than having to write all this code. With object-oriented programming, the idea is that the code is very self-commenting. If I call an object and I say, print yourself out, then I expect it to print itself out. If I tell the object to get the area, I expect it to get me the area back, right? I don't need to know as a developer. If I don't make the object, if I'm coding the class, yes, I need to do this. But, okay, you coded this rectangle class, and now you're giving it to your coworker. Your coworker does not need to know the internals of this class and how it's done. All they need to know is that get area is going to get them the area. That's all they need to worry about. They don't need to know what computations you did in there, what black magic you have to do to get this working. They don't need to know. Same with print. They know that print is going to print out whatever they need. That's it. They know that get width is going to get them the width. They know that get perimeter is going to get them the perimeter. Now, if you have poor variable names, that's why function documentation is good. And now, finally, by the way, for assignment, I guess, whatever the Twitter assignment is, now you actually can write, part of the rubric says that you have to write like function documentation, and now you have class documentation. Voila! Now you know what you're gonna have to write for that. That documentation is gonna be basically things like, what are your member variables? What are your member functions? Are they public or are they private? What does each one do? And so on. So that's the documentation that you want, because that's the documentation that your coworker would like to have to be able to use your class effectively. They don't need to understand too deep about the math involved to be able to compute this very advanced get area function. Maybe this is a rectangle. Maybe this is like getting the area of a country, like an entire country. There's like high math, advanced math to use. They don't need to know that. All they know and trust is that get area is going to get them the area of the country. And so that sort of abstraction of being able to use this without knowing how it works is one of the big powers of object-oriented programming and why it's so popular in the development world, because it just makes coding a lot easier without really having to know the nitty-gritty of the internals of things. You know, when you were using in vectors, you know, when you created a vector and you increase the size. By the way, a vector is a class, and now you can see why with the vector example. Maybe I can pop it open to point that out. That might be a good idea. So let's pop open the vectors. You see the little dot there? That is the member access operator. And pushback is a function. That is a mutator function, actually. It's actually inserting something into your vector. However, wherever it's kept is, I would say, a private variable, because there's no easy way of accessing it. How do you access it? You can go and do this system. You know, actually, maybe it's not private, not as private as I would think. Yeah, but you can access it that way. You can also pop out if you want to delete something. Or actually, yeah, pop deletes, I think. Yeah, so you can pop things out to get them out and so on, delete them. And so these are functions in the class. Erase is a function in the class. That's a mutator function as well. It's going to actually erase. It does take some parameters so it knows what to erase. Begin is a function in the class. So these are all functions using the class and struct system that I showed you. That's why the dot is all over that. But even as something as basic as size is accessing, and that's an important one. So this is a very, 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 very good example of something you want to keep private. With vectors, the size variable keeps track of how big the vector is, which is critical for the thing to work correctly. If the size is wrong, you're going to segfault at some point because it's going to go out of bounds or bad things will happen. So size is an example of a variable that you want to keep private so that a bad user that doesn't know what they're doing is like, oh, I inserted something into my vector. Maybe I should increase the size variable. You're like, no, don't do that. The developers already did that for you. That you don't have to worry about that. All you really have to worry about is just putting things in and putting things out. And if you need to know the size of it, you can call the size function, and that's going to be your access function that's going to go into the bucket, get the size, and return to you the number of the size. But not actually the size variable itself. It's just a copy of it. Why? Because that variable is mission critical for this thing to work. If somebody goes and messes with it, the whole thing breaks down. Maybe they don't intend to. Maybe they just think by accident that they're supposed to increase the size whenever they insert something. That is why you don't have a way to access that. With size, it's an example where there's only an accessor function. There's no mutator function. That is all happening internally. When you insert something, when you do pushback, somewhere inside the pushback code, there's code that actually goes in and increases the size. But that is done behind the scenes, and you're unable to mess with it. And that's a good thing. You don't want people to mess with that because that's how they break code. You want it to be like a happy world where everything is like full of cushions around you so you don't hurt yourself. Like, you know, when you have a little kid and you cushion the entire building because you don't want them to hit a sharp corner, right? That is kind of coding for you. You want everything to be very cushioned so people don't accidentally break things and hurt themselves, I suppose, you know, hurt their code. So yes, that is size is a very good example of that. So anyways, structs are all around you. Classes are all around you. You've been using them all semester long, but it is until now that maybe you begin to understand that. So hopefully that is all good. You know, I hope that made sense. It's a lot of information for a short amount of time. What else do I want to say about structs? I will give you another example in a minute, but any other important pieces? Oh, this is a good one. You kind of already saw this happen, but I'll try it. You know with arrays, you can't do this thing where you can just see out them, right? So you should be asking yourself, can I do that with structs? And what does that mean? You might be thinking in your head, well, if I see out the struct, it's going to print out just the variables, the member variables, right? One after the other or something. No, this will not work. It's going to give you bigger. Somewhere at the top, it's going to say it's not overloaded. Operand types are OSStream and rectangle. No match or operator. What does that mean? That means that the compiler does not know how to actually print out a rectangle. Yes, you have a print function. You can use that, but it doesn't know how to actually use the OS stream here with the rectangle. It's like, huh? Question mark. And so, yeah, that's kind of the same thing with arrays. It doesn't know how to print them out. So the solution is, of course, you can make your own function. In 202, we will learn how to overload operators. So you could do something like this. You can definitely write code to make this line of code work and actually do the same thing as print. I actually have a video of that already on my YouTube channel because I did record a video on operator overloading. It's like an hour-long video though. But if you want to check it out, you could definitely give that a shot. There might be some things that you might not understand because I might mention things that we haven't talked about. But I don't think I should. I think it's very self-contained. But yeah, that's of course beyond the scope of the course. But for now, know that unless you do some coding magic, which is called operator overloading, you cannot do this. Okay, just like you can't do it with arrays either. What else? I guess similarly, and I guess I never did show this with arrays, but I hope that was somewhat obvious. I want to sneeze. Is you can't read in either like this. That won't work either. So dog is back. So yeah, you can't just read in like you're like, oh, that's just gonna read into my length and width together. No, that's not gonna work. Yet again, you can overload operators to make it work and actually make it read into length and width, but not by default. Same with an array. You can't just make an array and do cin and assume it's just gonna like read into your array like magic. That's not gonna work. Okay, you can't do math or subtractions or things like that. So you can't do it with an array either, as I showed you, but you can't just do rect1 plus 1 and assume that it's going to increase your length and width by 1. No, that's not going to work. Again, you can overload operators to do it, but not by default. And if you do overload operators, that actually was an exam question that I made people do in 202 actually. I gave them 3 currencies, euros, dollars, and pounds. And I said overload it so that when I do +1 of my wallet class, it would increase everything by 1. And that was in the test. That was like I think it was a midterm exam question. So yes, that is in your future. Oh, this is a nice thing between structs and arrays. A little comparison. Arrays are always passed by reference to a function, right? There's no way you can pass an array by value when you're passing it into a function. With structs, you can do value or reference, actually. So that opens a can of worms if you have an array inside a struct, because you can have an array inside a struct, by the way. I didn't quite show you that, so maybe I should throw it in. No, I'll do that with the next example. Yeah, let's do that with the next example. This is already too big. So let me get rid of that, make sure this still compiles and runs. Okay, so let's go ahead and close this, and I'll talk in the meantime. So basically, with a struct, you can pass by value and pass by reference. I actually showed you both. Basically, if you pass by reference, you've got to be careful that you might modify it. And when do you want to pass a struct in? If you're using object-oriented programming, you might be like, I'm never going to actually pass a struct in. But you might, because this is baby steps. You can definitely have a struct inside another struct. Like you can have a struct of structs. You can also have an array of structs too. You can make an array of these rectangle objects. I can make 20 of them. That one is actually quite trivial to do. Maybe I should have done that one real fast. So what if I wanted to make an array of structs? Easy. Go ahead and just rectangle rec list per se 10. And now let's make a little for loop that says for. Can I use that? Can I use a range for loop with arrays? I don't actually remember. Let's try it. I don't think this is gonna work, but who knows? Could learn something new. Hey, it worked. Cool. Hey, that works nice. Perfect. So internally, there must be something that keeps track of the size of the array. The media lied to us. There is a way to store that somewhere internally they keep the size. So anyways, here I went ahead and created an array of rectangles, basically. As you can see, they all have weird garbage in them. That's because I never initialized them, you know, I just created them. By the way, in C++ 11, it is perfectly legal to initialize things like this. And so what that's going to do is that's going to set everything to 0 until further notice, per se. As you can see, whereas before we had garbage in both width and length, now we have garbage only in width and not in length. Length is everything is set to 0 nicely. You can also initialize this to 1 so that things look cooler. Now we got numbers in there. Yay. But yes, this only will work in C++ 11. If you try it in C++ 98, it will not work. So what this does is when you initially create the object, so when you do rec1 like this, or when you create an array of them like I did here, they have garbage in them, right? The member variables are garbage in them. There is what is known as a constructor, which we won't talk about, which is how you actually can initialize things by hand. But, you know, again, we're not talking about that. So the other easy way to sort of have an initial value to these member variables is just to set it equal to that like that in my actual struct here. As you can see here in the struct, it's kind of hard to get it all in one in the screen, but I'm declaring my struct. I have all my functions and whatnot, and then I have just the equals here. I could do this, but I could do this. So, you know, if it's always nice to initialize your variables, and if not, you have to go by hand and initialize each of them over here. So this is a much nicer way of doing that without knowing how constructors work, which is the ideal way of doing this. But this is a nice solution for you know, for quick and easy. So, but yeah, back to this. This is how you declare a rectangle an array of rectangles. So now we got 10 rectangles. We could even make a 2D array. We could just add another dimension right here, but I'm not going to do that right now. So that's pretty cool though that range for loop worked just fine with an array, because this is not a vector, but it worked fine. So yeah, it's cool. That's how you make an array of structs. How do you put it? How do you put a array in a struct? That I'll show you in a different code because this is getting too big. But yet again, there is one more thing I want to show you here. This is strictly for your benefit. This one I will not put in the test at all, but this is good for you to know. Suppose that I wanted to put the getWidth function outside. I told you that there is another way that I can declare this function so that I don't have to have the body. So I can just do this and do like a function prototype-esque thing. Why do I want to do that? A, that makes my struct be so much nicer looking than to have like a billion things in it. In fact, that might be a good thing to do actually for, not for this function, but let's do that for the print function, because that's the one that's kind of really big. So this takes a lot of bulk. Would it be not nicer if all we had to do here was just put this part like that with a semicolon afterwards? Because that would make this actually much more compressed. However, we still got to put the body of this somewhere. So how do you do it elsewhere? Things get a little bit tricky with these things. So with these stuff, you need to make sure that these functions are defined before you use them. You can't get away as easily by putting them beneath code as you can with other function prototypes. But you can definitely put them at least outside the code. And so how do I actually define it? This will not work like this. This one won't work. This is a global function. This is a member function. So I need to find a way to declare and define, well, we already declared we want to define the print function that is of the rectangle class. For that, we are going to use what is known as the scope resolution operator, which are 2 colons. Using that, yep, okay, have to remember. What you do is you have your return type, but then before you put the name of the function, you put the name of the class or the struct that you're working with, and then you put the scope resolution operator, and then you just keep going and do the same thing. Bam, done. This works now, or at least it should. Yes, it works now. Cool. That's all you gotta do. So, whereas with a normal function, you know, you put your prototype and then you just put the body as normal. When you're defining outside of the struct or class a function that is a member function, such as print, because print is a member of rectangle, it is inside the rectangle class declaration, but we are sort of defining the body outside because we didn't feel like doing it inside. Why? I don't know. I guess, like I said, it maybe looks nicer to because I mean, this would look nicer. Like if we, in fact, we should probably do this with set width as well. Yeah, let's do that with set width, because you'll see how much nicer this looks if we start taking things out. It's just so much easier to read. Like, look at that. This looks so much cleaner now. And if we did the same thing for get array and get perimeter, it would be so much easier to read what the rectangle is and what it does. We don't need to see the body of that. We can look elsewhere. Ah, we just killed everything. All right. So now here, how do we change this? How do we actually put this outside properly? Again, this will not work. You need to tell it that this is not just a global function. This is a function of the rectangle class or struct. How do I do that? Tell it it's a rectangle function. And then how do you say it belongs to that? Scope resolution operator, which are the 2 colons. Why is it complaining? Huh. Struct rectangle has no member get width. Does it not have a member get width? Did we lose that at some point? Did I delete that? Line 49. Yeah, what happened to get width? We must have deleted that at some point. I guess it got lost amongst the copy and pasting. Not to worry, we can bring it back. I do wonder where it went. We did have it at some point. So, anyways, double get width. Rewind the video and see where that disappeared. We'll actually do it outside as well, because why not? More practice. It probably got lost when I was copying and pasting some of the code. Double get width, return width, and then here we need to put rectangle again. Scope resolution operator. So. Yeah, I don't know where that went. Code was lost. MIA. So there you go. Okay. So this, as you can see, looks much cleaner when you don't have the body of the function inside of this. But it's when I'll be the first one to admit guilt that when I code, I usually code like this with the code inside the function. This is, by the way, known as an inline function. That's the technical term, but because it's inline, I guess. But it's so much better to do this, and it actually works internally different when the code gets compiled. I don't want to go too much into that, but in theory, sometimes it's better to do it this way because it's a little bit faster. But I just code like that because it's so much better. And then when I'm done coding, I usually go and move it out as literally as I did here. And yeah, because although sometimes when I know I'm not going to code the function immediately, sometimes I will not code it inside. But if it's something that I know exactly what I'm going to code, something which is like a very simple getter or setter, then yes, I just go in and put it in like this. But if it's a big function, then I'm like, oh, jeez, I got to do this. Then, yes, I'll do it like this because it's kind of like a to-do thing for me. And then I go on to its side. For the purposes of this class, either one works fine. I don't expect you to remember this. But it's a really good thing to know, actually. So, you know, after all, you're in this class not... Hopefully you're in this class not because you want a pass and get a good grade, but because you want to learn the material. And a positive side effect being that you get a good grade. But primarily to learn the material, right? Because remember, this is a big thing for computer science people, and I might get flack for this too, but whatever. You don't need a degree to get a job as a software engineer. You can go out there and learn more than you could with a degree if you go right out of high school and start coding. So if you're in a computer science degree, it must be because you really love the stuff. Or maybe you want to go to grad school. That's a different story. But yeah, so if you're here, then you might as well learn the stuff, because nobody's going to care in a computer science environment, you know, how you did on these classes. They just want to, they're gonna give you a coding test, and that's how they're going to know that you actually know how to code. Not because you got an A in 135 or whatever. So it's a good and bad thing, because I mean, that you don't have as much pressure to get amazing grades, but at the same time, that does mean that you better learn the material, because otherwise you could go and show them your straight A, 4.0 GPA, and then they give you a coding test asking you to write FizzBuzz, and then you screw it up, and they're like, well, it was nice meeting you. So yes, that is the hard and dark truth. So make sure you learn this stuff and actually know it. So okay, this is the biggest code that we've written, right? That's good. So what else do I want to say? Let's see. IO, assignment, arithmetic, comparison, parameter passage, return as a function, return to a value. I guess we didn't show you that one. How can I do this easy way to understand? I don't know in this example if I can really throw it in, but you can definitely return a rectangle as an actual value that you return. Oh, I got a good one. So suppose that we want to make an increase by 1. Oh, this is really tricky. I guess copy plus increase. Okay, this might work. Yeah, why not? Okay, so we're gonna make a little function that is gonna take an existing rectangle and it's gonna make a copy of it, but the copy is gonna have the same dimensions plus 1 on each of dimension. Okay, I don't know why, but that's what the boss said to do, so that's what we're gonna do, right? Okay, so because we want to return a brand new rectangle, the return type is actually gonna be rectangle, and that's kind of why I want to show you this example. I want to show you that yes, you can have functions that return custom data types. So rectangle is going to be, and maybe for that, do we want to make it a member function? Let's not make it a member function first, because it just feels weird. So we'll do it outside. So rectangle is going to call copy and increase by 1. Bad name, but whatever. Okay, so this is going to take a rectangle. I'm going to call that R1, or we're calling it rec OG, rec original. And what we're going to do is, I'm going to show you both ways. Outside the, this will be perfect. We'll show you how to do it outside the function, and then outside the class, and then inside the class, so you can see the differences in code. So we will do a version that is inside later on. So first we got to make a brand new rectangle. We're going to call it rec new. And then we want to set the dimensions of it. So we can't do this. Actually, we can for length, because that one is public, so cool. So this is saying, take the original's length, rec OG's length, and set it to rec new's length. Okay? However, we cannot do that with the width, because that one is private. However, so now I'll prove it to you by trying to compile. It's private. It's private. Okay? So both you can't access and you can't set it. So that's why we got the warning twice, or the error twice. Not to worry. We can use the getWidth function that will access the width. So that solves us getting the width from the old rectangle. But we still need to set it on the new rectangle. For that one, we can use the, think about it, what is it? What am I going to say? I'm going to say set width.
have to do dramatic pause because we're having remote lecture instead of in-person lecture, right? Otherwise, hopefully one of you would have yelled it. However, we need to pass the parameter, so I guess what we're going to pass as a parameter is going to be that. So that's actually a pretty nice line of code because I want to make sure you understand that. This code is calling another function. So we are saying rec news get width. We're going to get that information and then we're going to pass that value into the set width function. So that will actually take care of that. And finally, we can just return rec new. And so now let's see if this works. So, well, first let's compile, make sure it compiles. It compiles. So now down here, what I'm going to do is I'm going to make a new rectangle. Actually, I could use one of the ones that I have in the array for some reason, but yeah, why not? So let's just take rec list spot 0, why not? And that's where we're going to store the, we're going to print it later on, so let's just do that before we forget. Here, we can do it before and after. Before it's already in the array, but just so we can see it easier, I'll print it again. Because we already printed it in the for loop, but yeah. Okay, so put some spaces in there. And then we're going to call reclist print before, then put more spaces. Then we're going to call it again, but this time we're going to call our function. I forgot the name of the function already. What was the name of the function? Copy. Okay, copy something. So copy. It's a global function right now, so just copy and increase by 1. And we got to pass it the old one, so we're going to pass it reclist 0. Okay? And then we're going to print it again so that we can see if it actually worked. Oh, rect. Rec. I don't know where the T came from. Okay. Ready? All right. So this is the before, and this is the after. Damn it. End line. Really bothers me when there's no nice end lines. Be glad I'm not grading the assignments, because otherwise you lose so many points for that. So anyways, so area, width, length, and perimeter. So in theory, length and perimeter should have been increased by 1. Did they? Length did not get increased, and width got increased by some weird, scary number. I don't know, did it? Let's see. We created the rectangle. Where's that? Where's the thing at? Rec new gets set width. Return rec new. And then this is definitely before and after. I'm not 100% sure what went down because the numbers are all weird. Let's actually use. Let's copy. Oh, well, that makes it weirder. Here, I have an idea. Let's just copy down rec1, which we know what the data of that is. That'll make it a little bit easier, I hope. So our length went from 1 to 5. Oh, did I not ever increase it? That's why. We just copied over. Yes. I think. No, but then okay, so the way that I did it right now is I just copied it. So this is more of a copy than an increase. So we'll leave it as copy because really that's all that's happening here. We forgot to increase it by 1. But even then, this isn't working. I have a suspicion as to why, but I want to make sure. So we got the values at the end, which are 1 and 2, and then we are copying that, and it is not returning it. I'm not sure as to why that is happening. I have to think about it. It might be possibly the return here is doing weird things. Return rec new. Get the width. Oh, I see. Ah, typo right there. You see that? Does anybody see why? Right there. I'm highlighting it why. No. At least this one is because of this little piece here. Was the length okay? I wonder. Yeah, the length was okay. So see, so it was copying the length just fine. It's the width that was messing up. And I see the error now. Do you guys see what the error is? I'm highlighting it, but you actually see why? Like, why is this wrong? I'm highlighting the reason why. But do you actually understand the why? This is one of those errors that you're gonna face one day. Yes, it should be OG. That's right. Because right now, what I was doing is I was getting the new rectangles width and setting it again. But the new rectangles width was garbage. So I was taking garbage and setting garbage from the old one. So the problem was I was getting the wrong rectangle. So yes, it should have been OG. And then now, that fixes it. So yes, we got the original data, and then we're copying the data from rectangle 1. So yes, of course, now we can go ahead and do what we wanted to do originally, which we wanted to add 1 to these, right? So we can just do that by saying +1 here. And come on, dog. It's like dog is doing things. And then here inside +1. And so now these numbers should become 4 and 6. There you go. So now we did, because otherwise, if we just wanted to copy over, we could do that with the. We could have just done that. Like if it's no fun at all. If we do something like, you know, rec list, let's say 1 equals to rec 1, like that, you can do this. That actually works just fine. That doesn't work with arrays, but it works with this. And even then, it's dangerous to do when you're using dynamic memory allocation, which we're not talking about in this class. But because of that, this is kind of dangerous thing to do, using just the equal sign. But if I go ahead and run this, you can see here that this is literally a copy by using the equal sign. So the equal sign that you're looking at right here, this equal sign, and then that equal sign to 1 allows me to copy over rec1 into rec list 1. So you can definitely copy objects like this. It's a little bit dangerous when you're using dynamic allocation. We're not using dynamic allocation here, so it works just fine. But if we were, then it would be a very dangerous thing to do. Anyways, the cool thing was that we have a function that copies and increases by 1. And so in that case, we need to do it by hand, like we're doing here, and we're also adding 1 to it. So that actually works fine as well now, because you can see that it went from 3 and 5 to 4 and 6, basically. So this is all good now. So yes, but see, I'm kind of happy that we got that error, because it's a very typical thing that can happen is a semantic error where we called the wrong variable name. We were trying to set the new with the new when we were supposed to copy the OG into new, the original into the new one. So I'm glad I picked it up. I could have totally spent 10 minutes and missed it out and then found it right after the lecture ended, and then would have been kind of sad. So yeah. Okay, last thing we're gonna do is go back over there, Doc. We are going to make our little copy rec thing, which should we call copy and increase again, since that's a more meaningful name. So let me just change that here. Okay, works fine. And then I also wanted to add a line feed there. The last thing we're gonna do is I'm gonna make this function, the copy and increase, be a member function of the class. Okay? So same functionality, but in fact, you can even have the same name, exact same name. You'll see that's okay. But we are going to make it a member function, okay? And I guess we'll do it inside first, and then I can move it outside. So it's going to be very similar to the code that we had there. So we're still going to have a rectangle rec new. And then we are still going to have, actually, we don't need to say, yeah, we do. Here we do need to say rec new dot length equals, and here we don't need to say, actually, what am I trying to do here? Okay, yes. So I could leave it. Actually, yeah, okay. Sorry. I keep switching what I want to do, but now I've decided what I want to do. Okay, so we're gonna make an identical function. This is kind of a. It's not a good idea to do, actually. It's kind of pointless to do. A more interesting to do would be to copy the current object into the new one. So, yes. Now that one is for sure. We're gonna. Okay, so what we're gonna do is take the current object and copy it to a new one. That's what we want to do. Okay. So because of that, we don't need to say rec.og here. We can just say length. And then for rec new width, we can say width. Now, here's the cool thing. This is why I want to show you this. Assuming that I can actually spell things right, because I went in lowercase this when I was in this uppercase. This is a little trippy, okay? So, this is the same functionality in a way, because the way we're going to call this, and I'll show you. Let's say we're calling it on the rec list2, since we're going down the line with these variable names. Okay, so rec list2 equals rec1, but in this case we're going to do rec1's copy and increase like this, and then just print it out. And this will work, but then I'll explain why. Okay, but first I want to show you that it works. Rec2, rec1, let's see, make sure. Probably messed up the new and OG things again. I gotta make sure I didn't do that. Rec1 copy and increase, rec2 length and width. Oh, yeah. Return rec new. Okay, there we go. It's interesting that it compiled without that, but anyways, okay, so it works out fine now. All right, so now that it works fine, let me explain the big why here. And there's a reason why I wanted to show you this special scenario. And this might be confusing a little bit, and if it is, just block it out of your mind. But if you get it, then you will transcend as a programmer. Okay, so we are doing this copy function, and the way we're doing it is we are saying basically rec1's copy. So we're calling it on object rec1. So when we call it like that, because we're calling it like that, we don't need to specify rec new as a parameter. Rec.og, because rec.og is the object that we're being called upon. So we can call it with length and width, no problem. That's not the cool part. That's just how this works. We of course create a new variable of rectangle type, and then we return that. The cool part is why we don't need width to be set width there as we did out here. Here's the reason why. And this is trippy. This function is a member function. It can not only access any private variables from its own object, it can access any private variables from any object of the same structure class. So in this case, rec new here is a brand new object that we just made. But because we are within the context of this member function, it can access any object that you actually pass a reference to. So any rectangles that you pass in, it can access all of the private variables without requiring any sort of permission. That is why we don't need to have the set width function here or here. This one though is easy to understand because this is our own width. So yes, of course we can access it. It's our own width because it's our own object. But we can also access it. So this is like saying, think about it this way. Suppose you have two buckets in the room. The messenger function is the only one that can access things, right? But guess what? A messenger cannot only work with the object it's within. It can access any other object in the vicinity that it knows that exists. And it can go in and out. So like messenger has a VIP pass, not just to go in and out of your bucket, but in and out of any bucket. Take that as you may as a good or bad thing potentially. But in our case, we're going to use it for good, and as we are doing here. So Yes, it's a little bit weird. Maybe you're all like, what's the big deal? Well, it is a big deal because we're not using get set width. So we are, if width was a private variable, we'd still be able to access it. So it's a big deal. So hopefully that made a little sense, but if it didn't, don't worry too much about this example. I guess last but not least, let's move it outside. I went too far. There we go. Okay. That was the closing of the struct. So now all we got to do is put rectangle here and the colons, which are these scope rest operator. And then just to make sure that we didn't break it. Yep, still works just fine. So this looks weird too, by the way, but it makes sense if you think about it. This is the return type. This is the class that this function belongs to, or the struct. And then this is the name of the function. So different than this. This is a global function that belongs in the global scope, which is why it doesn't need anything. In fact, I think if I put those like that with just nothing in front, I think it'll still work just fine. Nope, it actually didn't like that. Oh, I see. It's connecting it to that. So never mind. I guess it didn't work. Ignore that then. I was thinking because remember the other day we were trying to figure out how to access global variables, and then Madi, our TA, said that you could use the colons, and it worked. But it works in that scenario. I guess it doesn't work in this scenario here. So yeah. Any questions? It's a lot of information. We basically, what I did today was we covered structs. There is one more thing about structs that I will cover next time, which is putting an array inside of a struct. And that's kind of what we will focus on tomorrow. And I'll show you more cool, neat tricks about structs, and maybe we'll just do more examples. And that'll pretty much prepare you for the Twitter assignment, which, while it can be done without structs, it's so much nicer and cleaner to do with structs. And that's a really cool assignment that I came up with. I think it'll be fun. So, yes. It's basically a little bit of data analytics. So, yeah. Any questions? How do you guys feel about structs? We got 17 viewers. We got 3 minutes, so. Like I said, all that I show you today can be applied to classes. Just basically the public and private being the only difference. Most people will use class and then even set it to public by hand. They don't like using the word struct. But you can. Struct comes from, if you're curious about the history of it, comes from the C language, which was mostly just meant to keep variables. You did not keep functions in there. In fact, it wasn't meant to keep functions. However, C people were pretty smart, and they're using pointers. They actually are able to keep functions in there and mimic C++'s functionality or object-oriented programming functionality. So that's the reason that we really have the struct keyword. Because you're like, if struct and class are so similar, why do we have the keywords? It's more of to be backwards compatible with C. And C++, while it's its own language, tries to be as backwards compatible as possible with C. And it is for the most part, with some exceptions. Such as the idea of a void pointer, which is a 202 subject. Okay then, well, there are no questions. Yes, there is indeed a lot of information today. Useful information though. So yes, there's a lot of content. I will definitely try to get this up as quickly as possible. So I usually just start uploading as soon as I finish. So cool. All right then. Tomorrow's Friday, and then 4th of July weekend. So hopefully tomorrow maybe we can even finish a little bit early. We'll do our best. No guarantees, but either way, I'm pretty sure tomorrow we will finish the entire content of the class too. So that's great. So all right then. Okay, guys. I'll see you guys tomorrow. Have a good day. Get assignment whatever it is, the Battle Royale assignment done. I'll be on Discord. See you guys later. Bye. Thanks for coming.